Hello, we're back, and in this third and final video lecture, we're going to finish our discussion on health data collection, data quality, and hospital statistics. Let's have a look. One of the things that we talk about in healthcare frequently is poor data quality. And this kind of goes back to the famous garbage in, garbage out kind of mentality type of thing. And the premise is if we enter inaccurate data into a computer system, then we're going to get inaccurate information out the other end, just as we would in a manual system. One thing that we talk about is data integrity. Data integrity has data that is accurate, complete, consistent, and up to date, and it's the same all the time where the data is recorded. Data reliability is when data is consistent throughout all systems that it's stored, processed, or retrieved. And then finally, data validity is data that conforms to an expected range of values. Healthcare data has to be monitored to make sure it's of the highest quality possible. The American Health Information Management Association developed a data quality management model, and this is achieved by managing the data application, collection, warehouse, and analysis. And when you use the term application, we're talking about the purpose for which the data is collected. In other words, the why. The data collection is the process itself. How are we getting these data elements? The data warehousing is the process and the system used to store the data. And then finally, the data analysis is the process of translating the data into useful information. CQI is a term that's been around a long time, the continuous quality improvement. And this is a way that we monitor the quality of data. We don't just collect it and assume that it's fine because we got everything straightened out initially. We need to continuously monitor the data and make sure it's accessible, that it's accurate, that it's comprehensive, right? That we're collecting all the data that we need and that it's consistent. We also need to have data definitions. These are defined meanings and values for all elements to understand the data. A term data granularity is the definition of each attribute and value of data at the correct level of detail. In other words, is our data detailed enough? Finally, we have data precision, relevancy, and timeliness. Timeliness speaks for itself, but precision involves accurate data collection. And then relevancy is making sure that we're collecting the right relevant data. All hospitals keep statistics. These statistics cover the number of patients that are admitted, discharged, and the length of stay. We'll cover more on these things in HIM 200 in healthcare statistics. But these statistics give us a benchmark for making meaningful decisions for the hospital. And even though a lot of this has now become automated through mainframe and PC and electronic health record systems, HIM professionals are responsible for overseeing the process. We're the ones that are responsible for ensuring that this information is accurate. And of course, admission data is meaning how many people are admitted. These types of subcategories of admission data include things like the daily census count, the daily inpatient census, and the average daily inpatient census. The length of stay is how long patients stay in. The total length of stay is calculated for a beginning time period. This could be the total number of patient days, what have you. We also calculate the average length of stay. So in other words, if we take the total number of length of stay for all patients who are discharged and divide it by the number of patients who are actually discharged, we'll come up with an average. This could be average length of stay for 3 days, 5 days, what have you. Discharge data is the same thing, except, or similar, I should say, except it's talking about anything related to a hospital discharge, right? This could be death rates, infection rates, so on, right? Discharge data statistics are reported to both federal and state agencies. And again, when we want to look at calculating discharge rates, we divide the number of times something happened by the number of times something could have happened. So if we had one hospital death over 100 hospitalizations, we'd have a death rate of 1%. Thanks so much for watching. We'll see you online. Feel free to reach out about any questions that you have on this material. Bye now.